Welcome to today's Explainer. We're jumping right into a meticulous, step-by-step breakdown of how to manually fly the Bombardier Q400 to a safe, perfectly stable landing. While modern automation handles a huge chunk of our flying today, mastering that manual visual segment is really what separates a good pilot from a truly great one. So we're going to break down the exact physics, the geometry, and the cognitive cockpit triggers you need to basically grease that landing every single time. Here's our flight plan for the Explainer: approach fundamentals, pitch and power datums, managing visuals, hard landings, the perfect flare, and non-precision approaches. We are not skipping a single step here. All right, let's dive right in with a quick trick to help you memorize the core elements of literally any approach. Just think AGS via RPP. Your alignment, glide, and speed are directly controlled by your roll, pitch, and power. Alignment is mostly managed by roll, which isn't too tough unless you're battling strong crosswinds. But managing your glide and speed using pitch and power, well, that is where the true art of flying the Q400 really lies. Now, your aiming point is your absolute target. The very first thing you need to do after disconnecting that autopilot is to lock this point right onto your windscreen. If you were watching it while the autopilot flew the ILS, you notice it's sitting perfectly still on the glass. So when you take over manually, your job is to physically fly the aircraft along that exact same constant path so that aiming point never, ever moves. Moving on to pitch and power datums. This is all about building your foundation. Now, this is a real game changer. The math here becomes incredibly simple if you use the pitch flip roll and the torque math trick, which are based on your landing weight. Okay, for pitch, if you're at flaps 35, your pitch is 0 to -2 degrees. If you flip to flaps 15, your pitch actually flips to 0 to +2 degrees. And flapless, it's +4 degrees. For power, use the torque math trick. For flap 35, just take your weight in tons and subtract 5. So a 2610 aircraft needs 21% torque. Easy, right? For flap 15, subtract 10, which gives you 16% torque. Memorize this, and your foundation is absolutely rock solid. Section 3, managing the visual segment. With our datums mathematically set, what happens when we look outside? Well, the crucial thing here is identifying your deviations super early so your corrections are, microscopic. If your aiming point starts moving toward the top of your windscreen, you're on a steep approach, flying short of your target. You've got to pitch up to move that point back down. Conversely, if the point moves toward the base of the windscreen, you're shallow, flying ahead of the target, and you need to pitch down. Identify early, correct small. So, how do you actually know if your rate of descent is right for your speed? You use the hi-fi trick. Literally, just multiply your ground speed in knots by the number 5. That's it. This gives you your target feet per minute for a standard 3-degree glide. And because it's based on ground speed, not airspeed, it perfectly accounts for any headwinds or tailwinds you might be fighting. As we get closer to the threshold, the whole geometry changes. Once you drop below 200 feet, whatever you do not chase the poppy lights. A tiny dip in your flight path turns those angular lights red. And if you chase them by pitching down, you're just going to increase your rate of descent right before you hit the ground. Instead, use a cognitive trigger. Actually say the word steady out loud to yourself. Lock in that pitch and just fly visually toward your aiming point. Next up, hard landings and deviations. We need to know what causes them so we can avoid them completely. Runway slopes will literally trick your brain. If you hit an unanticipated upsloping runway, it requires a much larger change of attitude during the flare. If you miss that cue, you're looking at a hard landing. On the flip side, a downsloping runway needs a much smaller attitude change. Flare normally there, and you're going to float forever, causing a long landing. This is exactly why you always have to brief the runway slope. If we look at the flight data recorder, extra speed is the #1 culprit for long landings. That extra kinetic energy just causes the Q400 to float way past the touchdown zone. Also, adding power during the flare, don't do it. It increases lift from those massive propeller blades and makes you balloon. Oh, and watch out for night landings with bright edge lights. They create this wild illusion that you're lower than you actually are, which prompts a high flare and, you guessed it, excessive float. Section 5, the perfect flare sequence. We are on short finals now. The most critical thing to remember here is fighting the ground effect. As you drop below 100 feet, the air starts compressing under the wings, acting almost like a cushion that increases your lift. The aircraft is naturally going to want to ride up on that cushion and balloon. You absolutely must anticipate this by keeping a light forward pressure on the control column. If you forget, you'll be forced to pitch down later, and that increases your rate of descent exactly when you want it to be decreasing. Okay. Here is your exact flare countdown. If you followed this timeline to the letter, it's a flawless maneuver. At 200 feet, check your speed, pitch, and power datums. At 100 feet, dial in that light forward pressure for the ground effect. At 50 feet, shift your eyes all the way down to the far end of the runway. Between 30 and 20 feet, apply back pressure to check your rate of descent. And finally, at 10 feet, raise your attitude to exactly 4 degrees of landing pitch. And now, the final physical steps to get this 26-ton machine safely onto the tarmac. You hold that 4-degree pitch until those main wheels are firmly planted on the ground. Only then do you pull the power levers back to flight idle. Seriously, do not cut power in the air. The drag from those props will drop you like a rock. Once you're down, smoothly fly the nose wheel onto the runway, keep it on the center line, and apply progressive braking. Finally, non-precision approaches. Let's see what happens when we don't have an ILS. The training manual is pretty clear here. FMS VNAV, using your magenta needles, is the preferred mode because it mimics an ILS approach so well. But if you find yourself having to use a VOR and vertical speed approach with the blue needles, get ready for some intense monitoring. Your pilot monitoring has to give continuous altitude versus DME callouts. You absolutely cannot drop below that safety profile. If you are flying that VOR approach, keep this golden rule in mind. You have to pad your initial rate of descent at the final approach fix. Just add 200 feet per minute to that number you calculated with the hi-fi trick. Why? Because you have to overcome the physical inertia of the aircraft as it pushes into the descent. Once you're established, then you can smoothly adjust right back to your standard datum power. All right, let's lock this in with a quick summary of the absolute do's and don'ts. Do, shift your gaze to the runway end at 50 feet. Do, initiate your flare at 20 feet. Don't ever chase those Populites below 200 feet. Don't increase torque during the flare. And whatever you do, don't push the control column forward on short finals. That is a guaranteed, bone-rattling, hard landing. I'll leave you with one final, incredibly important thought straight out of the manual. If any of these parameters fail, if you're too high, too fast, or just unstable below 1,000 feet, you can always go around. A go-around isn't a failure. It is literally the ultimate mark of good energy management. So the next time you find yourself wrestling the controls at 50 feet, ask yourself this: is your training flying the airplane today, or is your ego?